Welcome back, class. So last time we looked a little bit at the scientific method, and this time we're going to delve in to this topic called matter. Right? Now, why matter? Well, if we look at sort of a basic definition of what chemistry is, right, whole topic of this class, right, it is the science that tries to understand how matter, right, or we might generically call it chemicals, we'll just call it matters, right? But how matter behaves by studying how the atoms and molecules that make up that matter behave. And so the definition of chemistry kind of gives us a little hint here into what's going on, in the idea that, well, matter, right, is made up of atoms and molecules, right? So we're going to look at that atomic level, that molecular level, and look at behavior there to try to then understand or explain how what we might call the bulk matter, right, what we can see, how that behaves. And so the properties of matter are determined by the properties of the atoms and molecules that make it up. So what are these two things? Well, an atom is, first of all, a submicroscopic, so it's very, very tiny particle that is the fundamental building block of matter. Sometimes we refer to this as the smallest identifiable unit of an element. And remember, the elements we can find on the periodic table, and we'll dive into elements on a more detailed level in a chapter a little bit further down the road. Now, what about a molecule? What's the difference? Well, a molecule is just simply two or more atoms joined chemically in a specific geometric arrangement. You might also see a molecule defined as the smallest identifiable unit of a compound, which we'll define specifically a little bit later. And so, if we look here at our water molecule, we can see that this molecule is made up of two or more atoms, right? In this case, we have three atoms, right? One oxygen and two hydrogens here. And they are bound together, right, by chemical bonds. So when we say they're joined chemically, meaning they're attached by chemical bonds. And with a specific arrangement, right? We can see the sort of shape and how these atoms are bound together in a water molecule, right? And all water molecules will be this way. And so atom, molecule. Now, one of the things we want to do with the matter is to be able to classify it. And so we're going to talk about two different ways that we can classify matter. Now, before we classifying it, we should put a specific definition on what matter is, right? We've just sort of talked about it in terms of what it's made up of, atoms and molecules, but what is it specifically? Well, very simply, it is anything that occupies space and has mass. Now, sometimes we think about this and we say it has volume, right? So sometimes we'll say anything that has volume and mass, right? So, or that volume being it occupies some space and mass. Now, this may not be very much volume or mass, but there'll be some. Now, we have these different kinds of matter, right? Whether it be atoms or molecules, these kind of things, and we can classify them. We can group them, right? Scientists like to group things in different ways. And we're going to look at two different ways that we can classify matter. We're going to classify it by its state of matter, and we're going to classify it by what we call composition. So let's first just look at the states of matter. So there are three states of matter, which I know you're all familiar with, but we'll just run through them real quick. We have a solid, we have a liquid, and we have a gas, right? So solid, liquid, gas, these are our three states of matter that we'll be dividing things into. Now, as on a side note here, just to kind of build up here, if we look at solid, there's actually two types of solid. We have what is pictured here in sort of our classic diamond and salt and sugar, these kind of things. These are what we call crystalline solids. And crystalline solids have a long-range order or pattern, right? They repeat. And you can see by looking here at this blow-up of diamond that we have a bunch of carbon atoms all bound to 4 other carbon atoms in this repeated fashion, right? So it's a very ordered repeating pattern. So this would be things like diamond and sodium chloride and sugar. There's another type of solid called an amorphous solid. Which simply has no long-range order. And these are things like glass, like window glass. Many plastics, these kinds of things, right? Where they don't necessarily have this same type of long-range pattern. So while we're talking about our phases of matter, let's remind ourselves, maybe from the past course or something, the differences between these different states of matter. So let's think about a solid, right? If we have a solid, right, we associate a solid with atoms are close together. So they're packed very close, and it has a fixed shape and volume. Right? So it doesn't change its shape or volume based on where you put it. So if I have a round ball bearing, it's going to be a round ball bearing whether I set it on the table or put it into a 5-liter container or whatever. It's fixed. Now, if we compare that to a liquid, right? Liquids are also packed close together, right? So very much like a solid, the molecules are packed very close together, but they do have more freedom of motion. So where solids, the atoms or molecules that make up a solid can simply sort of vibrate in place. In a liquid, while they're close together, they have the ability to sort of slide around, to move next to each other, to move past one another. And this is what allows liquids to have their different properties, that we say that it has a fixed volume, but a non-fixed shape. So, while it does have a fixed volume, so if I have 1 liter of water, it is 1 liter of water, whether it's in a 1 liter container or a 5 liter container, right? It doesn't change volume, but its shape will change, right? If I put it in a square container or with a round container, right, it will adapt to whatever the shape of the container I put it into, right? So this is why liquids can be things like poured and flow through pipes, etc. Now finally, if we think about how a gas is different from these, so a gas is, the atoms are far apart. So unlike a liquid and a solid, they are not close together, right? And so they are far apart and have a lot of freedom of motion. And they have a non-fixed volume and shape. So essentially, they will adapt to the volume and shape of the container that they're allowed to occupy. So the atoms will move far apart or closer together depending on the volume and or shape of the container that the gas is put into. One last thing about gases is that they are what we call compressible. So unlike liquids and solids, gases are compressible, and all that simply means is that we can apply pressure and change the volume, or reduce pressure and allow the volume to expand. So we can compress it and expand it. And they have this ability because the atoms are far apart, right? There's a lot of empty space. And so we can push the atoms closer together, the atoms not close together, or allow them to go further apart. So the only state of matter that is compressible. All right, so now let's move on to talk about our second method of classification, and that is classifying things by composition. So if we look at our flowchart here, we see that we can break matter down into two categories. We have what are called pure substances and mixtures. So if we look at pure substances first, so there are two types of pure substances, right? Elements and compounds. And so what makes these pure, right, is there is only one type of matter, right? Either one type of atom or one type of molecule. So if we want to define these a little bit, right, or look at some differences, right, we got an element here. An element cannot be broken down. So it exists in this way. It's its simplest sort of unit, right? So if I have helium, the element helium, it exists as individual helium atoms. It can't be broken down any further. Whereas a compound So I said we're going to define that. So a compound contains two or more different elements. In a fixed, definite proportion. So this goes back to what we were talking about a little bit ago, where I brought up the definition of a molecule, right? Remember, a molecule was just two or more atoms chemically bound to one another in a specific shape. Well, a compound specifically has to have two or more different elements, right? So, for example, one of the things that we sometimes will talk about is that oxygen, for example, exists as O2 gas, right? So two oxygen atoms chemically bound to one another, right? This is a molecule of the element oxygen, right? But this is not a compound, right? Because it only has one kind of element in it. In order to be a compound, it has to be something like water here, where we have two or more different elements. So while water is a molecule, it's also a compound. So that's sort of the basic definition there. But again, we use the term molecule to define or to talk about an individual unit of a compound. So we'll say a molecule of water. Right? Now the other key part here is that the elements within this compound are always there in the same fixed proportion, right? So it is always two hydrogens, one oxygen, two hydrogens, one oxygen. So every molecule of the compound water is identical, the same proportion of the atoms. So pure substances, elements, compounds. Now, should also say that a compound can be broken down into the elements. So water can be broken down into hydrogen and oxygen. Mixtures, so let's do mixtures. Essentially, a mixture is more than one type of matter, right? So mixture is essentially two or more pure substances combined together. And those substances can be combined in two ways, right? They can be either heterogeneously mixed or homogeneously mixed. And so heterogeneous simply means that, as we see the picture, if we were to look at the mixture, it is not the same everywhere. So in this wet sand, some areas of this have more water and less sand, like up here. Some areas down here have more sand, less water, right? So it's a non-uniform composition. We call that heterogeneous. Something that is homogeneous usually will look like it is one material, right? It'll look like it is just one type of matter. But that's because they're mixed in a homogeneous way, right? The composition is the same everywhere within this mixture. So no matter where I look, I'm going to have the same makeup or the same distribution of whatever the materials that are part of this mixture. So we got heterogeneous versus homogeneous. Both of these things can be separated into the components. And there's various ways that we can separate it. And some basic ways to separate the components of a mixture might be something like filtration. So sand water could be something as simple as running it through a filter paper to separate the solid from the liquid. Or something a little more complicated like distillation, right? Which separates by boiling point. So if I want to separate the water from the sugar in this tea, right, I could heat it up and allow the water to evaporate or boil off. And because the sugar boils at a much, much higher temperature, right, it's going to stay around, and you'll be left with the sugar in the cup and the water evaporated away. Right? So different ways that we can separate, but the key is they can be separated. So now we have composition, right? We have pure substances, mixtures, two kinds of pure substances, elements and compounds, two types of mixtures, heterogeneous and homogeneous, based on how they're mixed, their composition. Okay, the last topic I want to look at here in this section is properties of matter. So we have two basic types of properties and changes of matter that we can talk about. We can talk about physical properties and changes, and we can talk about chemical properties and changes. And fundamental difference here is that the physical property can be observed without changing the composition of the matter. So these are things like odor, taste, color, boiling point, melting point, density. These are all examples of properties that can be measured without changing the composition. Right? Temperature would be another example, right? Where the boiling point is a temperature measurement. Right? And so a physical change, right, comes into it, is a change in which the matter does not change. So, for example, dissolving or boiling, etc. Any sort of change of state, melting, freezing, etc. Right? We're just changing its physical state. We're not changing what it is. Now, chemical properties and changes are essentially kind of the opposite, right? Chemical properties, let's use a different color here. Chemical properties can only be observed by changing the composition. And that means a chemical change, or what we will commonly call a chemical reaction, the composition of the matter does change. So, some examples of chemical properties here, things like flammability, corrosiveness, toxicity. So these are things that we can only sort of measure them by changing them. Like if we want to see how it burns, what temperature it burns at, these kind of things. We have to burn it. And if we do that, that is going to change the composition of the matter, right? So, chemical changes here, some examples that we might run across are things like burning, right? Or what we're going to call combustion, rusting, right? Which is an example of a corrosion, bleaching. Right? These are just some basic examples of chemical reactions that you might be familiar with. And these are all going to involve physical change, right? The matter, the composition of the matter is different at the end than it was at the beginning. Okay, so this brings to a close our discussion of the basic ideas of matter and how to classify them, the different types, some of the things about the physical and chemical properties and changes of the matter. And next time, we'll talk a little bit about energy aspects of matter.